Right now, at this very moment, a star somewhere in the universe just exploded. Another one was just born. And our sun? It's halfway through a cosmic journey that will end in 5 billion years. Every single star in the cosmos follows the same incredible life cycle: birth, youth, middle age, old age, and death. But unlike humans, when stars die, they go out with the most spectacular shows in the universe. As of June 2026, astronomers have mapped over 200 billion stars in our Milky Way galaxy alone. And every single one is on the same path. Some are newborns, some are ancient, some are in their final moments. In the next 11 minutes, you're going to witness the complete life and death of a star. You'll see how they're born from clouds of dust, how they live for billions of years, and how they die in ways that create the very atoms in your body. This is the most important cosmic story you need to know, because without stars dying, you wouldn't exist. Let me show you why. Stage 1. The stellar nursery. Stars aren't born alone in empty space. They're born in massive clouds of gas and dust called nebulae. These clouds are enormous. We're talking hundreds of light years across. Inside these clouds, something incredible happens. Gravity. Tiny variations in density cause parts of the cloud to collapse inward. As the gas falls together, it heats up, it spins faster, it gets denser and hotter. The center of this collapsing cloud becomes a protostar. It's not a real star yet. It's still gathering material, still heating up, but it's getting close. The temperature at the core is rising. This process takes about 50 million years for a star like our sun. That sounds like forever, but in cosmic terms, that's incredibly fast. The universe is patient. Stars are not rushed. Then, something magical happens. The core temperature hits 10 million degrees Celsius. At that exact moment, nuclear fusion ignites. Hydrogen atoms smash together to form helium. Energy explodes outward. Congratulations. A star is born. The radiation pressure from fusion pushes outward. Gravity pulls inward. These two forces reach a perfect balance, and the star enters the longest phase of its life. This moment happens thousands of times per day across our galaxy right now, in 2026. New stars are constantly being born. The universe is always creating new lights in the darkness. Stage 2. The main sequence. This is where stars spend most of their lives. Our sun has been in this stage for 4.6 billion years. It'll stay here for another 5 billion. During the main sequence, stars are incredibly stable. They're fusing hydrogen into helium in their cores. Every second, our sun converts 600 million tons of hydrogen into helium. Every single second. This sounds like the sun is losing mass incredibly fast. And it is. But here's the thing. The sun is so massive that it can keep this up for 10 billion years total. It's got fuel to burn. Not all stars are created equal, though. Massive stars burn through their fuel way faster. A star 50 times more massive than the sun might only live for 3 million years. They live fast and die young. Smaller stars, on the other hand, are incredibly efficient. Red dwarf stars can live for trillions of years. That's longer than the current age of the universe. Some red dwarfs born early in cosmic history are still in their youth today. The main sequence is comfortable. It's stable, but it can't last forever. Eventually, every star runs into the same problem. It runs out of hydrogen fuel in its core. When stars use up their hydrogen, they don't just turn off like a light switch. They don't go quietly. Instead, they enter their most dramatic transformation. For our sun, this will happen in about 5 billion years. But we can watch other stars going through this stage right now, in 2026. We can see our future written in their present. This brings us to stage 3, and this is where things get wild. Stage 3, the red giant phase. When the core runs out of hydrogen, fusion stops. Without fusion pushing outward, gravity starts winning. The core contracts and heats up even more. But here's the weird part. While the core is collapsing, the outer layers are expanding. The star swells up to hundreds of times its original size. It becomes a red giant, or if it's massive enough, a red supergiant. When our sun becomes a red giant, it'll expand past the orbit of Mars. Mercury, Venus, and possibly Earth will be swallowed completely. The sun will consume the planets that once orbited it safely. Meanwhile, the core gets so hot that it starts fusing helium into carbon and oxygen. It's like the star found a new fuel source. But this fuel doesn't last nearly as long as hydrogen did. For massive stars, this process continues. They fuse carbon into neon, neon into oxygen, oxygen into silicon, silicon into iron. Each stage happens faster than the last. It's a countdown to catastrophe. The final stage, fusing silicon into iron, takes only one day. One single day. After millions or billions of years of life, the star has just 24 hours left. Why does it end with iron? Because iron is the most stable element. Fusing iron doesn't release energy. It actually takes energy. And when a star can't produce energy anymore, it's game over. For stars like our Sun, which aren't massive enough to fuse beyond carbon, the red giant phase is gentler. The outer layers drift away as a planetary nebula. Beautiful, glowing shells of gas expanding into space. But massive stars? They go out in the most violent events in the universe. Which brings us to stage 4. Stage 4. Supernova. When a massive star can no longer support itself against gravity, the core collapses in less than 1 second. 1 second. The core, which is thousands of miles across, collapses to just 12 miles. The collapse happens so fast that the outer layers don't even know it's happening yet. They're still falling inward. When they hit the incredibly dense core, they bounce. This creates a shock wave that rips through the entire star. The explosion is called a supernova. For a few weeks, a single dying star can outshine an entire galaxy of hundreds of billions of stars. One star, brighter than billions. In 2026, astronomers detect several supernovae every single day in distant galaxies. They're happening constantly across the universe. Right now, as you're watching this, stars are exploding billions of light years away. During a supernova, something amazing happens. The intense heat and pressure create elements heavier than iron. Gold, platinum, uranium. Every heavy element in the universe was created in supernovae. The explosion scatters all these elements into space. They mix with clouds of gas and dust. Eventually, they become part of new stars, new planets, new life. You are literally made of stardust. Literally. The calcium in your bones, the iron in your blood, the oxygen you're breathing right now. All of it was forged inside stars that died billions of years ago. You are the universe experiencing itself. But the star story doesn't end with the explosion. What's left behind is equally mind-blowing. That's stage 5. Stage 5, the remnant. What's left after a star dies depends on how massive it was. For stars like our Sun, the core becomes a white dwarf. A dense ball about the size of Earth, but with half the mass of the Sun. White dwarfs are incredibly dense. A teaspoon of white dwarf material would weigh about 15 tons on Earth. They're so hot they glow white, but they're not producing energy anymore. They just slowly cool down over trillions of years. For more massive stars, the core becomes a neutron star, even denser than a white dwarf. A neutron star packs more mass than the Sun into a sphere just 12 miles across. A teaspoon would weigh 1 billion tons. Neutron stars spin incredibly fast. Some rotate hundreds of times per second. They have magnetic fields trillions of times stronger than Earth's. They're the most extreme objects in the universe. Except for one thing. If the star was massive enough, the core collapses past even a neutron star. It collapses into a black hole, a point of infinite density where gravity is so strong that not even light can escape. The ultimate cosmic grave. So that's it. The complete life cycle of a star. From clouds of dust to fusion-powered furnaces to spectacular deaths that seed the universe with the ingredients for new stars, planets, and life. It's the most important cycle in existence. If this completely changed how you see the stars in the night sky, do me a favor. Hit that like button and subscribe to your Space Wizard, because we're just getting started exploring the mind-blowing wonders of the universe. Every star you see tonight is on this journey. Some are being born right now. Some are in their prime. Some are dying as you watch. And billions of years from now, the atoms in your body will be part of new stars continuing this eternal cosmic dance.